A promise represents a value that you don't have yet. It comes from an asynchronous operation, which means you have to understand promises if you want to work with APIs or a backend system. In this video, you will learn exactly how promises work, and we'll apply that knowledge with a real-life example, how to fetch data from an API. JavaScript is single-threaded. It can only do one thing at a time. But our apps do slow things all the time. API calls, database requests, or file operations. If JavaScript just waited for each of those to finish, your page would completely freeze. So we need asynchronous code. That means we can start a thing that we know is going to take a while, like a fetch request. And instead of waiting in that line of code, the rest of the code will continue to run, only when that slow thing is ready, meaning when the promise was resolved. We continue with that part of the code in a then block, for example. Now, fetch returns a promise. But how does the syntax of a promise look like? The best way to learn this is when we take a look at how to create your own promises. Let's create a new promise. A promise has three possible states. When it is still doing something, it is pending. After the operation finishes, it is either fulfilled or rejected. The promise constructor takes one argument, a function. This function is called the executor. The executor receives two parameters, resolve and reject. We can call resolve when the operation succeeds. So if we actually had some code here, we could create a simple if statement to check if the operation was successful. For simplicity, our operation would just be a simple 5 plus 5. Now, if the operation was successful, and the answer is actually 10, in that case, we want to resolve the promise. So we call resolve. Else, if it wasn't successful, we have to reject the promise. So call reject. Inside this function, you can send something too, like a simple string. Now we can attach a reaction to this. We want to react differently depending on whether the promise was successful or not. And for that, we can use then and catch. We take our promise and call .then on it. Inside then, we get the value that was passed into resolve. So this string right here, we can call it message. So this console log happens if everything worked. In here, you could update your web page, return some data, or even trigger the next step in your logic. Now to handle the case when something went wrong, we use .catch at the end of the promise. Inside catch, we get whatever was passed into reject. In our example, that's the rejected string over here. So it is also a message. In case of an error, we could just show an error message on the console. So let's try this out. When 5 plus 5 is 10, the operation will be successful, and the promise is fulfilled. Now, if you make a mistake on purpose, the result won't be 10. Then the promise will be rejected. So the code in the catch block happens, which is the error on the console. Now, of course, the response doesn't have to be a text message. You could also return complex data, like objects, for example. Now, even though our current example isn't truly asynchronous, it's perfect to understand the syntax. You can imagine whenever we do an asynchronous operation, like calling fetch, then something very similar will happen behind the scenes. This fetch call will make a request to an API. The function returns a promise, which is fulfilled with a response object representing the server's response. So, on that promise, we can do the same thing as before. We use then and catch to do something if it was successful or not. Let's see how that works in practice. In this example, I want to know about the weather in New York. So fetch is going to make a request to the OpenMeteor API. So it talks to their server and asks for a forecast at those coordinates. But the important part for the promise is this. Fetch immediately returns a promise. It does not wait until the server's answer. That promise will eventually resolve in a response object. So in the first then, we get the response as the parameter. Now this response isn't the weather data yet. It's just the HTTP response wrapper. So let's log this to the console to see how it looks like. We can see all sorts of properties with all the information about the response. For example, the information if the response was okay. Let's check that with an if statement. If the response is not okay, we throw an error. If it is okay, we can return response.json, because APIs usually communicate with a text format called JSON. And to convert the data into an object that we can use in JavaScript, we have to call response.json. But we are also returning the response, because response.json itself returns a promise. And whenever you return a promise from a then, the next then in the chain will activate. So the next then will receive the resolved value. Here we have data. That is the actual JavaScript object that we need to get to the weather data. For example, we can do a simple console log. Now usually you would have to find out a lot more about this API, but I know that the temperature is a data.currentweather.temperature, because I tried this out before. Now we can see the temperature in New York. So everything worked perfectly. But in case something goes wrong, we should add a catch block to log the error. For example, if the user is offline, then the promise will reject, and the code in the catch block will run. In here, I do a simple console log. Now, if you make a mistake on purpose, For example, if we completely break the domain so the request can't reach the server, then the promise will reject. So the code in the catch block happens, which is the error on the console. That is just something you should know. Now, after this example, there's another important concept in promises you need to know, the .finally function. Sometimes you want to run a piece of code no matter what happened. So when you don't care if it was successful or not, finally will run once the promise is settled. This could be useful to stop a loading spinner, for example, or to re-enable a button that you disabled during an asynchronous operation. So let's imagine you have a simple isLoading state. Before we start the request, it is set to true, and in finally, we will always set it back to false. Now, depending on this isLoading state, you could show a loading screen, an animation, and disable form elements. Then, in .finally, all of this ends once the promise is settled. Now, at this point, I might mention that then, catch, and finally is just one way to handle promises. But you should definitely hear about the async and wait syntax. This is a newer way to write promise-based code, and you will see it everywhere in modern projects. Whenever you put the async keyword in front of a function, it means this function always returns a promise. If you return a value, JavaScript automatically wraps it in a resolved promise. If the function throws an error, it becomes a rejected promise. And very importantly, we need the async keyword in the function declaration so that we can perform an asynchronous operation with the await keyword inside that function. You put await in front of a promise. For example, fetch. This will pause the execution of that function until the promise is settled. Now, an important detail is it does not freeze the whole page or block the main thread forever. It just tells JavaScript, when this promise is done, continue here with the value. So in this example, we have 3 console logs. A is happening before we await the promise. B happens when the promise is resolved. And C happens after the code in the function. But if we test this code and look at the console, you would see the order A, C, B. So while we're still awaiting the value, the rest of the code down here can still happen. So first A happens, then we await the promise, in the meantime C happens, and when the promise is resolved, B can happen. Now, if a promise rejects, await will throw an error. And that is why we usually wrap await calls in a try-catch block. In the try block, we do something asynchronous, like awaiting a promise. And in the catch block, we handle any errors. It's the same promise mechanics under the hood, just written in a way that reads more like normal synchronous code. Now, if we try to rebuild the same weather API logic that we had before, but now using the async await syntax, how would we continue from here? First, we have to check if the response is not okay. In that case, I would throw an error with the status code. And if everything is fine, we can turn the response into real data. So below that, I create a data variable and await response.json. So this is exactly the same as the second then we had earlier. And just like before, we're going to see the temperature in the console. So under that, I do a console log and log the temperature, which is at data.currentweather.temperature. In the catch block, we can handle any errors. To keep it simple, let's do the same console error. And yes, we also have finally in this syntax. This block will run once the promise is settled. So here we could set the isLoading boolean to false if we had one in our project that was set to true previously. So no matter if the request was successful or not, the code in finally will always run at the end. Now that you've learned both syntaxes for promises, which one do you like more? Async await was invented to make it more readable, but I think they look pretty much the same. There is no one option that is better than the other. At the end,